Okay, can everybody see my slides?
Seems good here.
Yeah, fantastic. Yep. Okay. Right, so Scala for big data, the big picture. My name's Anna. I'm working at Advancing Analytics with Simon. So first and foremost, who am I? I'm a senior advancing analytics consultant. I specialise in data engineering and cloud, and I've got over 14 years experience working in software engineering and mostly recently working with Scala and Kafka and various other cloud tech. Prior to that, I spent over 2 years working for a Microsoft partner and championing a cutting edge data science project that was aided by a variety of Azure tools, including Data Factory, Data Lake Gen 2 and AKS. And I've got a BSc in multimedia computing and business and a HND in visual communications. My Twitter handle and LinkedIn are at the bottom there, but I will share my slides and share that again at the end as well. So what makes me tick? I've got a strong background in software engineering, but I have a passion for bringing the worlds of data and software engineering, data engineering closer together. I help to organise and run local code clubs, and I organise and volunteer at local events as well. And other areas of interest include UX, Agile and Agile methodologies. So I'm also involved with some meetup and community groups. So Women's Tech Hub in Bristol, trying to get more women into tech, and then Subject Data, which is a UK-based meetup. We have it in Bristol, Cardiff, and Swindon, but at the moment we are going online. So watch this space. There will be some interesting talks coming up in the next few weeks. Okay, so Scala, what are we going to do? So we're going to do a little bit of theory, so a Scala overview, look at a little bit of functional programming. Scala is a very daunting subject for a lot of people, so I will be going through the basics and breaking it down. So hopefully it won't be too scary, and you'll be able to understand what's going on. And then we'll be looking at a little bit of practical, some XML transformation to JSON, write JSON to a Data Lake Gen 2, and refine the data using Azure Databricks. So what I've done is I've taken a real world problem out of my day job. So before I was working for Advancing Analytics, I was working for a big energy company, and we had a lot of XML data coming in. This was payments data. So payments information coming in, lots and lots of data, and we needed to transform that into JSON, getting it into storage, and then essentially we were able to refine that and report on it. So, and also all of this, the code that I'm going to show you is on GitHub as well. The link's at the bottom, but I will share that at the end as well. So first and foremost, what is Scala? So it's a programming language that combines two quite distinct programming paradigms, and that is object orientation and functional programming together. Now, normally they're very, very separate paradigms, but Scala is an exception in that it has both of them actually within it, which is a good and a bad thing. Sorry, just bear with me. And what is Scala used for? So Scala is used for a lot of things. This is ranging from machine learning to web applications. It's a very diverse language, so it's quite a useful skill to have. And just an interesting fact, the name Scala stands for Scalable Language. And it's so named because it was designed to grow with the demands of its users. So as mentioned, Scala combines object orientation and functional programming paradigms. They're very different paradigms. So this picture makes me laugh because it is like a very strange love child of the two. You would normally keep them separate. But at the same time, it's its strength, especially if you're getting into functional programming, because it allows you to do normal object orientation or scripting techniques, but then also start to look at what you can do with functional programming and how that can actually aid you in your programming, especially with data ELT transforms. Now, some may say it could be the ultimate teaching language. A lot of people, when they first start learning programming, they'll lean towards scripting languages such as Python, especially with data science and data engineering, and also JavaScript, because they're easy to pick up and and yeah, they're easy to learn, and it's easy to get on your feet pretty quickly and get some stuff working. And this diagram here is just showing how Scala can actually fit in between all of that. So if you throw in some OOP languages such as Java and C#, Scala actually nicely fits in the middle. So if you're really serious about learning to actually program, Scala is actually quite a nice option, quite a nice road to go down, and it gives you a varied skill set. So who actually uses Scala? So I've done a little sales pitch about how awesome it is. Who's actually using it? So we've got some big names. We've got Netflix, Twitter, Airbnb, Foursquare, Sony. My absolute favourite is Disney Plus. I'm a massive Disney fan. So when I discovered that Disney were looking for Scala developers, I got really excited, and then realised that it's the other side of the UK and there was no way that I could relocate. But it's a pretty cool set of companies that are actually already using it, and they're using it with big data. Software that we commonly use that's written in Scala. The obvious is what we've already spoken about earlier with Simon, Databricks and Spark. You've also got Kafka, which is essentially a message queue, Play, which is an MVC framework, and APACHE. So Scala and fast data. I love this quote. Scala has taken over the world of fast data. It's a bit dramatic, but it's a good quote. So Scala is great for large amounts of data and for streaming. So in this diagram that I've got here, we've got some Azure tools, so Event Hub, IoT Hub, so bringing all of your messages in, Kafka, and then your data from storage blobs. And in the middle, we've got HD Insights and Spark. At Advanced Analytics, we'd normally go down the Databricks route, but you could use either or in here. You could swap that out for Databricks as well. And then at the other end, we've got Power BI for our reporting, databases, your data lake store, and Azure storage blobs. But I can hear you thinking, still, why bother? You already like you working with Python. Why should I bother learning Scala? So it's a very transferable and portable skill set. It's a very useful skill to have. It's multi-purpose, meaning you can use it from anything from a web app to machine learning. It gives the opportunity to actually learn functional programming and allows for easy transition into other languages such as Haskell, F#, and even Erlang if you are crazy enough to want to learn Erlang. It has a competitive skill set, so like I said, it's a useful skill to have under your belt and on your CV. It has a solid community behind it, so if you're trying to learn Scala and you want to know how to do things, there's a lot of people out there that will help you. And it is type safe. So type safety, for those who don't already know, means that the compiler will validate types while compiling and throw an error if you try and assign the wrong type to a variable. So what does this mean? It basically means that you can't turn a cat into a dog. If you've defined something as being a string, being some text, you can't then suddenly turn it into an int. So in scripting languages such as JavaScript and Python, obviously you can do that, and there are sometimes advantages to that. But in a solid programming language such as Scala, we've got type safety, so it stops you being able to have those mistakes already in your code that won't show up until you're actually running the code. It will actually say straight away in your compiler, this isn't going to work. So you can't talk about Scala without talking about functional programming. Functional programming is quite a scary, daunting area. But it's not that bad. I've got a category theory there. I'm not going to go into all of those. I'm sure that would kind of blow your brains a little bit and make you switch off. But what we are going to look at is MONADS. But just for reference, we've also got on the left, we've got immutable data closure, fast class reduction function, and just basic functional programming concepts. So MONADS. If you were to Google MONADS, you would get some really convoluted explanations as to what a monad is. And functional programmers love their MONADS. It's their bread and butter. But it's essentially, a layman's term, top-level explanation of what a monad is it's a sequence of events with a get-out-of-jail card. So your step 1, step 2, step 3 will be steps in your code, and at any point you are able to break out of that sequence and without all of your code completely blowing up and your application blowing up. So it's essentially, instead of having a big try catch around your code. So just quickly covering Apache Spark. So Spark is written in Scala. Spark itself can connect to lots of other data tools such as MySQL, Elastic, Redis, MongoDB. So if you're learning Scala and you're working with Spark and Databricks, there's loads of things out there that you can actually then connect to. Databricks, as Simon has already covered, it's basically derived from Spark, and it's for big data processing. So I won't go too deeply into that because we've already covered that, but I'm sure you guys are already aware of its strengths. So just Databricks again, sitting in between our data coming in, so our people side, data engineering, data science, line of business, and many others. Databricks sitting in the middle, essentially Apache Spark, that you can use Scala, and then at the other end, you've got streaming, your data warehouse, Power BI, and many more. Okay, so without further ado, just start with the basics of Scala. So we're going to look at some objects and classes, options, lists, map and flat map, fold and reduce, and 4 comprehensions. I will obviously relate this back to how you can use that in your ELT transforms, and we will be looking at some Databricks as well, but it's important to go through some of the basics first so that you can understand roughly what is going on if you're completely new to Scala or quite new to programming. So just reference, an object is basically in Scala is a singleton instance. You can use an object to create an application, so like a console application. So you'll see objects used a lot in the code that I demo, and here in this little snippet of code, we're literally just creating a console app. So whatever was within those curly brackets, that print line is literally the application. So case classes. Case classes are really, really useful in data engineering. A case class is like a model, and it is immutable. So any data you've got coming in, you can put it into your case class and define all of your properties, and it acts like your model. And it comes with a load of stuff out of the box that is really, really useful when working with data. So it automatically will generate equals and hash codes. So hash code being when you've got all your data in your case class, what that actually equates to. So if any of the values change, you can compare hash code and actually see that there's a difference in your data without comparing every single row. It's got an automatically generated copy method. So if you want to copy your model, your element of data, you can easily do that. Essentially, that's great for immutability. And you don't have to use a new keyword. You can just reference it without having to new it up every time. So a quick demonstration of some case class code. So we've got the object there, which is literally just the console app. And on the bottom line there, in line 7, we've got the case class employee that I've created, and it's got 2 fields: first name, which I've set as a string, and last name, which I've set as a string. So in our console application, we are saying a new employee, but you don't necessarily need the new. And we're saying Ada Lovelace, and then we're going to print out that employee and print out the hash code. So what we are getting as a result is that rather than saying languages such as C#, if you were to print out that object, you would get an object. When you print out that employee, you're actually getting the values. So you're getting employee brackets Ada Lovelace. So you've got that data there already. You don't have to do any casting to JSON or anything. It's already there out of the box when you're working with case classes. And the hash code is just like I was saying before. It's basically a hash of all of your values. So that Ada Lovelace, if any of that was to change, it would essentially change the hash code, and that's a great way to be able to do comparisons. So the null mistake. functional programmers don't believe in nulls. It's a little bit like Peter Pan and not believing in fairies. Every time they say they don't believe in nulls, they hope that a null will drop down dead. Sadly, that isn't the case. But they don't believe in having nulls in their code. And the quote here, I call it my $1 million mistake. It was the invention of the null reference in 1965, Tony Hoare. Essentially, nulls in a lot of programming languages cause problems. We've all had that null reference error pop up in our code. So functional programmers have said we don't believe in it. We've got other ways around it. And so how do we do that? So Scala has what we call options. So a Scala option holds 0 or 1 elements of a type, and it will either return you a sum, which is a value, or a none. So a sum is equal to something and a none is equal to nothing. So looking at some code here, we've got a list of countries. We're saying it's going to be an option. And then at line 14 to line 17, we're saying, right, show me those options. We're doing a match. So we're just saying for every value, if it's got something on line 15, then return the sum, which is the value. Else, if we've got a none, rather than saying if we've got a null, if we've got a none, then we know there's nothing there, and we can just return a question mark. Don't worry if you don't understand all of this code. We'll go into a little bit more depth in a moment. So by running that code, what we're getting here is it's saying, what is the capital of Japan? It's returning Tokyo, and then the capital of India, and it's saying, well, I don't have India in there, so I'm just going to return a question mark. So that case statement, because it was working with an option, was able to happily handle that without throwing an error. So Scala has a concept of map and flat map. Map takes a function and applies that function to every element of a collection. Not so useful when you put it into text, but if we just look at an example, so we've got our console app again. We're saying got a val of A, and we're going to say that A is a list of 1, 2, 3, 4, and 5. And then if we do a print line on that and do a.map, and so what we're doing with the map is we're saying for every value, and every value is represented by X, we're going to put that value into a list and then also have the value of 0 in that list as well. So our output at the bottom is we've got a list of lists, because we've said, right, output the list, but then for every value, create another list with the value and a 0 in it. So we've got a load of lists within lists. This is just an example, but it's great when working with data. So if that doesn't make sense to you, emojis might help. So map explained with emojis. We've got map. So we've got cow, chicken, sweet corn, and then we're going to say, right, cook it. And essentially, if you're working with a map, that would equal a burger, some fries, a chicken leg, and some popcorn. So essentially, that is in emojis what map is doing. So if that's map, what is flat map? Flat map for collections is a combination of flatten and map. What does that mean? Let's look at some code. So our console app again, our val A still list of 1, 2, 3, 4, 5, and we're still printing out the result of A. But then we're doing a dot flat map rather than a map. And so what that is doing, and you've got X equal to list, X comma 0, because we said flat map is going to attempt to flatten that. So it will, so we've got a load of lists within a list, but I only really want one list, so I'm just going to flatten all those lists down. So the result at the bottom is a list of 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. Explained essentially using cats, because you've got to have a cat picture in there. We've got 2 cats, and if you don't use a flat map properly, if you just use a map, you'll end up with the cat in a box and a box in the box with a cat, because you forgot to use your flat map. So for comprehensions, not to be mistaken with for loops, which are used in a lot of languages. For comprehensions in Scala are essentially a monad. Fold and reduce and filter, very similar to other languages. filtering is pretty much the same thing. Reducing is easiest to explain with emojis again. So looking at a filter here first, we've got burger, fries, chicken and popcorn, and saying, is it vegetarian? As expected, it just returns the fries and the popcorn. And then if we're doing a reduce, we've got all the food again, we're saying I'm going to eat it, and the outcome is poop. Okay, so let's look at the demo. Let's look at the actual code taken out of production. Is there any questions at that point? Sorry.
None so far.
Okay. Okay, so what I've done is I've taken what was a Lambda in AWS and put it into an Azure function. And what we are doing is we are going to grab some XML and turn it into JSON. So I've got the basic boilerplate function code for an Azure function to wrap around it. But what we're interested in, and once again, this is in GitHub if anyone wants to take a look afterwards, what we're interested in is parser.scala. Can it, just let me know if you can't see the code very well. I think it's big enough. So we're expecting this XML to come in, and we've got this class of parser. There's a load of stuff going on here. I don't expect you to understand it all, or for you to want me to go through everything at this stage. What we are interested in is this for comprehension, and this is where I was talking about MONADS, where it's actually going through step by step, stage by stage, and essentially if it breaks at any point, it should get out of jail card and it will fail nicely. So essentially what we have in this for comprehension is saying, I've got some XML, I'm going to parse my payload, which is the XML, cast it as XML, and then I'm going to extract my first name, my last name, and my age. Now, if at any point any of these fail, it will essentially, it's going to return an error. So why is it going to return an error? Because we've said in this function, in this def, that it's going to return an either. Now, an either in Scala is exactly what it says it is. It's an either or. It says either return this or return the other. You can also use tries in Scala, but it's a lot nicer to demonstrate using eithers, and also because you don't have to use it for errors, you could use it for many purposes. So what we're saying is I've got this error type, which is the case class, I've got an employee, which is a case class, and in this for statement, all of these functions also return an either of error and employee, and that's the type safety kicking in. And so every time it tries to get one of these elements, if it fails at any point, so if any of these return that error, it's going to bubble it back up, and it will return our error type. So just for reference, the error type is literally just a case class there with a reason of a string, and then that's our employee case class. So if I was to run this locally, it creates my function, and it will then essentially, because it's a short function, it's giving us, and it's a HTTP function. So it's just creating an endpoint for us. Obviously, there's lots of different Azure function types, but this is what I'm using here. So it gives us an endpoint that we can work with. Has anyone got any questions at this point?
I see that Simon had a question. No. That was about his session. No, sorry.
Okay, so we've got this endpoint. This is essentially creating a REST endpoint. So those who've worked with APIs before. So for those who haven't worked with Postman, Postman allows you to hit your endpoints, your REST endpoints, in a nice GUI interface, and then put in your body data and actually get the result and see what's going on with it. So I could put in my URL here, my local URL, but I've actually deployed this function into the cloud, just so that the demo gods are kind, and this definitely works. So this is essentially hitting the same code, so that same Azure function I've just got that for comprehension in it. A little bit slow. Right, so what I've got is the expected XML, which I'm parsing, and then the result is literally returning the case class, of which we have the first name, the last name, and the age. So it has transformed that XML into JSON, and this is a happy path. So this is all the rightly formed XML. If I were to go in and say remove one of the elements and do a send, because we've got that error case class, we've already defined what our reason is in our code, it literally comes back and says, could not find element, cannot find unique child, age. So that for comprehension has essentially handled that for us without us having to have a big try catch around our code. We've just been able to use our monad or for comprehension and built it up with our case classes, and it handles it all for us. Any questions at that stage?
No, sorry.
Okay. So right, so going into to Databricks. So I've got some Scala code here, which is working with that same data. So that is same employee data. And we want to grab that data out of the data lake in the raw folder and actually put it into a refined folder. So going into the Azure Storage Explorer, if we go into raw, so I've set up a raw and a refined folder in my Gen 2 data lake. So in the raw folder, I've just added an employee.json file, which is essentially the same as what we were just looking at. So this is the data landed into the lake from that Azure function, and we now want to actually do something with it. We want to actually do an ELT. Okay, so what I have got is I'm defining a case class of employee again. So this time I've added in an ID there as well, but it's essentially the same thing. We've got first name, last name, and age. And then we're going to do a read from the data lake. So that's the mounting that Simon was talking about before. I'm going to my raw folder and I'm saying, right, I know what this is going to be an employee. I know it's going to be in the right format because I've already handled that in my Azure function. So I'm going to say this is going to be as an employee, and that's my employee case class. And then just so it's easier to explain and easier to visualize, I've done my existing employees as just a static list of employees that I've already created. Normally this would actually be in your refine folder in your data lake, but it's just nicer to be able to have it on screen so you guys can understand a little bit more what's going on. So I've grabbed my new employee data and I'm saying, well, does this already exist in my refine folder? So I'm looking at my existing employees, which is here, and I'm doing a filter. So I'm saying, does it already exist? Can I find where the ID matches the ID and what I've got already? And if the exists has got a length of 0, it means, well, it's not already there, so I don't have to do any comparisons of the data. So I can do a write basically into the data lake, into that mount point of the refined folder that we were looking at a minute ago. Else, if we do find it, what are we going to do? So we do a map and we look to see, do our hash codes, and this is the case classes kicking in again, do our hash codes actually match between each instance of the case class? So that is essentially saying, I've got the same employee, but have any of their values changed? Has their first name changed? Has their last name changed? And we can do that via looking at the hash codes, which are automatically generated for us, and then saying, okay, there's a change in the data, so I want to do something with that. So that's nicely using a map there. But then what we're doing at the end is we've got a fold. So what is this doing? The fold is essentially saying, I only want you to return me what is actually true. So if you find me some matches, return it, and that is what a folder is doing. It's flattening it down a little bit, like reduce, and only returning what we're interested in. It is a functional concept and a little bit weird to look at, but it's a nice little example of showing a little bit of functional code within this example without overwhelming you with loads of functional programming. So yeah, so that's what that is doing. We returned matches, and we're saying, okay, so if you haven't actually got any matches, we can just write the data. So what we're saying is, so if it matches, then nothing's changed. I don't care, I'm not going to do anything with this. But if it doesn't match, then we want to actually do something. So here, what I've got in my comments here is you can do whatever you want transformation-wise here, working with the data, and then actually write it back into the data lake. So if I were to run this, the cluster is happy, started.
We have one question incoming from Nadim, who's wondering which is best, Scala or Python, when hiring data scientists, and more specifically, which profiles are easily available in Europe?
It used to be that Scala ran quicker on Spark and Databricks, but that's no longer the case. So I wouldn't say there is a preference either way. You have got a lot of Python developers. Scala developers, it is a more refined skill set, and it leans more into software engineering as well. So it really depends on the company you're working for and what sort of skill set and what they're actually going to be doing in their role as to whether you go down the Python route or whether you go down the Scala route. I don't want to say, oh, it depends, because that's a typical response, but it really just depends on what company you're working for and what would suit best your environment. Does that answer the question? There isn't a golden answer to that one. Does that answer the question?
Yeah,
sorry?
Nadim just thanked, so I guess the question has been answered.
Yeah. She's welcome to message me afterwards if she has any further questions or wants to go into more detail.
Okay, thanks.
Okay, so I've run this little bit of code here. I've done a display at the end just so you can see the data. So that's me, that's my ID, let's pretend age. So go into my data lake again and go into refined. So it's created all of these files. So what I'll do is I'll delete these and just run it again so you can see it creating. Right, so empty folder, go into Databricks. Should we just run this again? Should be quicker the second time round. Okay, so there's all my details again. Do a refresh in here. And so you can see here it's actually created that Parquet file, so that JSON file. So it's written it now into my refined folder. So this is a very basic example just of using Scala and Databricks. Here we could have some really crazy transformations and comparisons and stuff going on, but it's just a nice way to get started and looking at Scala working and just dipping into a little bit of functional programming and how it can actually help you when working with data. So okay, so useful links for anyone who's thinking of getting into Scala, who's interested in Scala. These are some of the areas that the tools that so there's some learning, online learning there, some useful websites that you can go to and get yourself started if you're interested in Scala. We've got the Disney streaming Medium as well. They do some really good blog posts on Scala and the stuff that they're doing. I think Netflix do as well, if you just do a search for them, which is really useful. Coursera is really good. They've got some good courses on Scala just from beginners working your way up. Conferences, obviously at the moment with the strange environment that we're in, they're not running at the moment, but normally you'd have Scala Days, Scala World, and also Scala Exchange, which is normally in December. It didn't run last year, but hopefully next year that'll be running again. So all of the code that I've demoed is on GitHub. I'm on LinkedIn and Twitter. I'm happy if anyone wants to message me, ask any questions, more than happy to answer. So that is it. I appreciate I'm on time. Have we got any more questions?